Good morning, everyone. Welcome to this course. We will explore strength of materials, a foundational pillar of engineering that bridges the gap between theoretical physics and safe physical design. Let me briefly describe or introduce myself. I am Dr. Habbar Ghania, Assistant Professor Class B at the National Higher School of Autonomous System Technology. For this semester, this course is tailor-made for you, our second-year undergraduate engineering students. Here you will find my professional email address for any urgent queries. Furthermore, I highly encourage you to use my scheduled office hours. I am available every Sunday from 9:40 to 11:10 and Mondays from 11:10 to 14. Please feel free to stop by my office during these times. This module is officially scheduled for semester 4. It is It is explicitly classified under the Fundamental Teaching Unit. This module carries a weight of 3 credits, a coefficient of 3. We have 1 hour and 30 minutes for formal lectures, also 1 hour and a half of tutorials where we will work through analytical problems and equations together. Lastly, we have a 30-minute laboratory session. The course is structured around 5 fundamental chapters as in the concept map. Chapter 1, Introduction and Generalities, introduce the fundamental principles of strength of materials. It covers the classification of structural elements, different types of loads, and a review of static equilibrium. Chapter 2, which is Geometric Characteristic of Plane Areas. Chapter 3, Axial Loading. It covers normal stress deformation and the relationship between load and elongation. Chapter 4, Torsion. It deals with the behavior of structural elements under twisting loads. Finally, Chapter 5, which is Pure and non-uniform bending. It covers shear force and bending moments, how to construct the diagrams, and the relationship between loads and internal forces. For the objectives, first you will develop the capacity to predict the exact internal behavior of materials when subjected to external forces. Then you will learn to apply rigorous strength and rigidity criteria to prevent mechanical failures. Ultimately, the core goal of this course is to equip you with the mathematical and physical tools necessary to design, save, and optimize. Strength of materials is high analytically, so you will need differential calculation, specifically derivatives and their practical engineering application. Equally important is integral calculus. Finally, a strong comfort level with vector algebra and coordinate system is mandatory. For our second category, which is mechanics, first, the static of rigid bodies, which forms the basis of structural behavior. Second, the calculation of external forces and moments acting on a system. And finally, setting up equations for the equilibrium of particles and rigid bodies. The third category is general skills. You need to be comfortable with the 3 case areas. First, unit conversion, that engineering problem solving mindset, and lastly, proficiency with your scientific calculator or software. We implement a comprehensive 3-tiered assessment structure designed to measure both your ongoing engagement and your final understanding. First, 20% of your final grade is allocated to continuous control, which includes regular quizzes, classroom participation, and tutorial performance. Another 20% is dedicated to your laboratory work assessment. The remaining 60% of your grade is determined by the comprehensive final examination at the end of the term. Thank you for your attention.